Let's start. So today we will be starting with AdaBoost. So we have already discussed there are two types of ensemble modeling techniques which are there. One is bagging, one is boosting. In bagging, what do we have is that we have multiple models, but all models have equal say, right? That is one important thing. And second important thing is that the models are created parallelly. Okay, no model is dependent on the other. On the other hand, in case of boosting, all the models do not have the same say. Some models will have more say than the others. So I think here, right, we talked about. So if there are multiple different models, then each model will have a different say depending upon how much accurate that model is. Okay, so that is one important thing. Another important thing is that the models are created in series. So first model 1 will be built. Using the output of model 1, model 2 will be built. Using the output of model 2, model 3, model 4, and model 5. Okay, so these two things we need to remember in bagging and boosting. In bagging, all the models have equal say irrespective of the individual accuracy of the model. That is one thing. And second thing is all models are independent of each other and they can be created parallelly. Right? They can be created parallelly. In case of boosting, models do not have equal say. The say of the model or weightage of the model will depend upon how much accurate the model is. More accurate models will get higher weightage as compared to less accurate models. And that is one thing. Second thing is the models are created in series. They are not created parallelly. That's the reason in general in boosting, we have a higher runtime as compared to bagging. Okay. Given this, let's start with boosting. Okay. And the base algorithm behind bagging and boosting both is decision trees. Even in bagging, we are creating multiple decision trees. In case of boosting also, we will be creating multiple decision trees. Okay. So let's start. So in the first few slides, you will be seeing that we will be talking about the same thing that we have discussed so far. So for example, this, yeah. So in case of random forest, if you remember, let me see if I can pull the code up or not. Yeah. In case of random forest, if you guys remember, we can tune these parameters. What is going to be the max depth? What is going to be the min sample lift, min sample split, number of models, and all of that, right? In case of AdaBoost, the maximum depth of the tree, okay? The maximum depth of the tree will always be 1. Okay, will always be 1. In case of random forest, the maximum depth of the tree can be anything. But in case of AdaBoost, the maximum depth of the model is always going to be 1. Now you tell me, if I will create a decision tree with let's say 4 or 5 depth versus if I will create a decision tree with only 1 depth, in which case I will have more accurate model?
With 4 and 5?
Not
With 4 and 5, right? Because with 4 and 5, it means that I'm using more number of variables, right? So I will be able to split it even more, the data set. With depth of only 1, it means that I'm using only 1 variable. Okay, so random forest is using decision trees to any depth. It can be 3, 4, 5, 6, 10, 11, 15, does not matter. There is no constraint. On the other hand, in AdaBoost, whenever you are creating models, right, the decision tree, the depth of the decision tree will only be 1, always. Okay. it means that we will only be taking one variable at a time. Cool. Now, it means that the models which are being used to create AdaBoost, okay, those are weak models, right? Because in random forest, we have like big trees. Let me draw it here, right? So in case of random forest, right, the depth of the tree can be anything. So let's say first I split it based on gender, right? If you remember the example of playing cricket versus not playing cricket, let's say first I'm splitting based on gender, then maybe I'm splitting based on class. Here I'm splitting based on height. And then maybe I'm splitting based on class. This is how a tree in the backend in random forest will look like. And how many trees can be there in random forest? Will there only be one or there will be multiple?
Multiple trees.
Multiple trees.
Multiple trees will be there, right? If there was only single one, then we will not be calling it random forest. We'll call just decision tree, right? So multiple decision trees will be there, and each tree can be of any depth. There is no constraint on that. In case of AdaBoost, okay, in AdaBoost also we have multiple trees, but each tree will have depth of only one root node, and after that, that's it. Okay, so obviously the decision tree that I am creating in case of random forest, that is a strong decision tree.
So random forest is bagging only, right? Yeah.
Yes, right. Yes. Okay. And in case of AdaBoost, the model that we are using, that is a weak model, weak decision tree. Okay. But still we will see that the way the AdaBoost work is, it will be able to combine weak models together to create a strong model. Okay. Multiple weak models we will be able to combine together to create one single strong model in case of AdaBoost. Okay. But this is one difference that you can also remember. See? So it is saying that in case of AdaBoost, we just have one node. And this kind of trees are called stump. Okay. Let's say, for example, if I will Google simply stump, let's see what we will get. See? This kind of a tree. This is a stump. Okay. So it means that, a tree which is kind of almost cut. So in case of AdaBoost also, we will be creating a lot of stumps. And then we will be combining them together to create a strong decision tree, strong model. Now, okay, so as I was telling you, so these stumps are technically weak learners. Okay, these are not very strong models. Reason being is you are taking only one variable into account and not all the variables. So the example that they have taken is that, let's say if I have this kind of a data set that I want to predict whether someone will have heart disease or not. Okay. So if I have this kind of a data set And if I'm creating a decision tree, then the decision tree will take advantage of all the variables which are present. There are 4 variables present. All the 4 variables will be used to create the final decision tree, right? And this decision tree will be more accurate. Let's say, for example, whether there is a good blood circulation or not. If there is a good blood circulation, then I'm checking whether there is a pain in the chest or not. If there is pain in the chest, then yes, you have heart disease. If you do not have pain in the chest, then no, you do not have heart disease. If there is no good blood circulation, then I'm checking weight. If let's say weight is above some threshold, then yes, you have a heart disease. If the weight is below a threshold, then I'm checking whether the arteries are blocked or not. If you have blocked arteries, then yes, you have a heart disease. If you do not have blocked arteries, then you do not have heart disease, right? So this is the full decision tree. But in case of stump, I will only be taking one variable. Let's say, for example, chest pain. If you have chest pain, then yes, you have a heart disease. If you do not have chest pain, then you do not have heart disease. Okay, which you can imagine is going to be a weak model. So in case of AdaBoost, multiple weak models will come together to create a strong model. Right? Other thing, what is the next thing that they are saying? In random forest, each tree has an equal vote in the final classification. I think we have already discussed that, right? Irrespective of what is the accuracy of individual model, each tree is going to have equal weightage in the classification. Even if a model is 60% accurate or a model is 99% accurate, both the models will have equal say in the final voting. Okay. On the other hand, when we are doing AdaBoost, then some stumps, they're saying some stumps will get more say in the final classification than the others. Why some stumps will get more say in the final classification based on what?
Accuracy.
Based on accuracy, right? The model which is or in this case the stump which is more accurate will get higher say in the final accuracy, sorry, final voting, as compared to the stumps which are less accurate. And I think this is also we have discussed. In random forest, each decision tree is made independent of each other. Okay, because they are being made independent of each other, they can be created parallelly. Because model 2 is not dependent on model 1, model 4 is not dependent on model 3. So all the models can be created parallel to each other, right? Because models are independent here, they are not dependent on each other, and hence they can be created parallelly. On the other hand, when we are doing boosting, okay, then the models are created in series, right? See, the errors that the first stump will make will influence how the second stump will be made. The way that I was telling you, that the first student will go and attempt the exam, and it will come back and he will tell which questions it found difficult. The questions it found difficult, the second model will try to focus more on those questions. Okay, then the second model will go and attempt the exam. It will come back and it will tell that which topics that model found difficult. And it will tell model 3 to focus more on those questions, and so on. So everyone is individually attempting the exam. Okay. So we have discussed this. In AdaBoost, we will combine weak learners. Second thing is, in AdaBoost, a few models will get more say than the other models, depending upon their individual accuracy. And last thing is, each stump is made by taking the previous stump's mistake into account. It means that the models will be created in series, one after the other. I cannot create models in parallel here. And that's why the runtime for boosting is in general very high. Clear? I think this is something that we have discussed before as well. Any question? Okay. Now we will start with.
How do you know that which feature is like have more accuracy? Like will be testing each feature.
Yes, we will be testing each feature and we will be calculating the Gini value for each feature. Wherever we will have the highest Gini value, that is the feature that we will be taking. Okay. Gini value is nothing but an indication of accuracy only. You can check accuracy for each variable as well. Both will give you the same result.
And one more thing, last time you told the Gini value is if it is more, then we are more accurate. But uh, uh, but when Gini becomes zero, then only you take a decision, right? Like zero or like it's like the leaf node will be zero, right?
No, I never said that.
No, I think
Huh.
I think last time you told that if a model is having more Gini value near to one or something, it's better. It is better, right? Like we are doing good.
Right, yes. Yeah, that's what I said. But about zero, I didn't say anything.
But actually, when zero, the Gini is less. Gini is like entropy only, error only, right? Or no?
No. So if you remember what the formula of Gini was?
1 minus p square.
Right. So it was p square plus
1.
1 minus p square, right?
Yeah.
Okay, what is the minimum value of this? We created a graph as well.
Yeah. So it was like 0.5 in the down, and it was it's a parabola. It's a curve from
Right.
one to.
Right. So the maximum value was 1, right?
Yeah.
When p will be 0.
Yes.
Okay, or p will be, let's say, 1. Both the cases, I will get 1.
Yeah.
And the minimum value was, I think, 0.5, right?
Yes.
So if my minimum value is 0.5, it will never be 0, right? Gini,
Yes. Yes.
right? So that's why I
Yeah.
was saying that I would have never said that the Gini is going to be 0.
Okay. But lower Gini is better, right? Like lower Gini is where you take the decision, right?
No. Lower Gini is actually bad. If you remember the graph that we had,
Okay.
here we had probability, right?
Yeah.
And we had this kind of a function, right?
Yeah.
Where it is minimum at 0.5.
Yes.
What is 0.5 here?
And the lowest.
No, that is the y value,
Yeah.
right? But this y value is also 0.5. This x value is also 0.5. What is 0.5 on the x-axis? P, right?
Yeah. P. Yes.
What is P?
Yes.
Probability.
Probability of what? Probability of, let's say, anything. Let's say if my data set is about playing cricket and not playing cricket, then P is going to be playing cricket, right? If my
Yeah.
data set is about heart disease, not heart disease, then P is going to be probability of heart disease. Okay.
Okay.
So
Okay.
now in a data set that we have, if you have exactly 50% of heart disease and remaining 50% of not heart disease, will you be able to make a better prediction here? Or let's say a second case scenario where, let's say, 10% data is of heart disease and remaining 90% data is of not heart disease. In which case you will be able to make a better prediction?
Okay.
Second
The
case.
second terms,
Right? Why second case?
because we have more. Like
What is the benefit of having more, let's say, not heart disease?
because the data is skewed to one side, so the skewed, like we know that okay, something is happening. We are very confident about. Yeah.
No. So let's say in this case, in this particular case, if you will ask me, right, that I need to predict whether someone has heart disease or not heart disease. Irrespective of what I predict, there is a 50% chance that I will be correct, right?
Okay.
So my accuracy is going to be what? 50%.
Yes.
In this case, if someone will ask me, randomly pick a person from this group, if you will randomly pick one person, and you will ask me whether he has a heart disease or not heart disease, what is going to be my answer? If I have randomly picked one person out of this group, I will say not heart disease,
Not that.
right? Why I'm
Yeah.
saying so? Because 90% data is of not heart disease, 10% is of heart disease. So if I
Yes.
have randomly taken one person out of it, in that case, if I will predict that everyone is not having a heart disease, my accuracy is going to be 90%, right? So
Yeah.
do I want this kind of a scenario? Or do I want this kind of a scenario? I want this kind of a scenario.
Second scenario. So then Gini is like opposite of entropy, right? Then.
Gini will be opposite of entropy. Yes.
Okay. Okay.
Okay. Yeah, entropy is also used in making the split, but it also does the same thing. Calculating the accuracy, calculating the Gini value,
I think
calculating everything.
I got confused when watching some video. Entropy, they're saying that when zero, it will be you are in
Uh-huh.
the leaf. So I thought same. Okay.
No, so everyone is kind of trying to do the same thing, right? It's just that they are different ways. As I was telling you, even if you just go by the accuracy, which variable is going to give me the highest accuracy, right? Even if you will go by that, even that thing will give you the same answer as Gini.
Yeah.
Okay. So there are different methods, but everything will lead to the same answer.
Oh, but we always calculate that weighted, right? Weighted Gini value for each node. If it
Right.
is if it is less than the root node, then we say it has improved the model. And then if you go
Yes.
down,
Yeah, you're right.
yeah.
Yeah. This was just for an
And then,
example, but you are right. Yes. So I've just taken here, I talked about only one P, but there will be two Ps related to two groups.
so we never look at the individual leaf node. If the Gini value is either towards zero or towards one, we will never say whether it is pure or impure. It's always comparable with the root node. Is my understanding right?
Hmm. No, why you are saying so? Why we are comparing first of all leaf nodes with the root node?
Uh,
Mm-hmm.
That's what
just
we did right in the last one.
Mm-hmm. No,
So if the higher Gini value split happens on that.
right. But leaf node can be anywhere, right? See, this is a tree.
Mhm.
When I want to split here, I will just check of all the variables which are available, which variable is having the highest Gini value, and that variable I will be using to make the first split, right?
Well, is it like individual Gini value or the weighted Gini value, weighted average?
Weighted, always weighted,
Okay, okay, okay.
right? So once you have done the weighted, then you will get a Gini value of a variable, right?
Right, yeah,
So I will look at all the variable and see which variable is having the highest Gini value, and based on that, the split will happen,
right, yeah, yeah,
right? Then what I will do is for this particular group, I will calculate again the Gini value of all the variables,
yes,
right? And whichsoever variable will have the highest Gini value, the split will happen based on that,
yeah,
right? Similarly, I will look at the Gini value of all the variables for this group, not for the root node, this group. And then
okay,
whichsoever variable will have the highest Gini value for this group, the split will happen based on that, right?
yeah,
And
yeah.
so on. And
Can we
now,
see a
now,
cortex?
now, which are my leaf nodes? My leaf node is this, and this, right? How it is related to root node?
Root node, what I meant is like, for the ones you have marked in yellow, right?
Mm-hmm.
So for that, the root node will be The one above it, right?
No.
That's what I meant, root node.
No, I got the feeling now, right? But that will be a wrong thing to say. Root node is
Okay.
only one. This one.
Okay. So I can say parent node for that.
Parent node, you can say.
Okay. Okay.
Hmm.
Yeah.
Yeah, here, what is Gini value?
Gini value Gini value is more like, what should I say? A method to know which variable is gonna give me more accuracy on this particular data set. Let's say if I have a data set, I have multiple variables here, right? Variable 1, variable 2, variable 3, variable 4. So Gini value tells me that which variable is going to give me the highest accuracy if used individually. If I'll use only variable 1, will that give me the highest accuracy? If I will use only variable 2, will that give me the highest accuracy? If I'll use only variable 3, will that give me highest accuracy, and so on. So whichsoever variable will have the highest Gini value, that variable is going to give me the highest accuracy, and that is a variable based on which we are going to split. Okay? Yes, Deepak.
One more question like that. Grid search CBS last time you did for the boosting. So that three is a 3-parameter max depth, mean sample leaf, and the mean sample split. Those threes, like I think control the overfitting part of the dysentery, right? So the when you do grid search, basically we make sure that we are not overfitting, right? Like with the parameter tuning is the finding the best parameters and to avoid overfitting, right?
Yes, you are right. That's one benefit of it. Although in case of any ensemble modeling technique, right? Because we are creating multiple models, the chances of overfitting are always very low. Okay. Why the chances of overfitting are always very low? Because see, what is overfitting? Overfitting is when one model start mugging up things. Right. To avoid mugging up, what we do, we want to generalize. Is that correct?
Yes.
Right. We want to generalize so that like I want you to know how addition works instead of you remembering that 2 plus 2 is 4 or 4 plus 4 is 8, or let's say 9 plus 2 is 11, right? Because if you just remember these things, then if I'll ask you a new question like what is 10 plus 10, you might not be able to answer, right? On the other hand, if someone has understood the concept, then if I will give him any addition question, he will be able to answer, right? So the problem of overfitting is in general happens when you're using only one model. The ensemble modeling techniques, any ensemble modeling technique, be it is random forest or it is AdaBoost or anything else, in general are always more generalized because there is not one single person who is taking the decision. There are multiple people together are taking a decision. Okay. So chances of overfitting are in general low in case of ensemble modeling technique. But yes, using grid search, we actually tried, whatever the little chances that we have, those chances also reduce. But the main benefit of grid search CV here in this case is not to reduce chances of overfitting, but to increase the accuracy. Okay, it is doing both. It is increasing the accuracy as well. It is reducing the chances of overfitting as well. Okay, but main reason behind doing this is improving the accuracy.
And this n estimator, the number of model also, like, can it lead to overfitting? Like you have creating lots of models, 1 lakh, 2 lakh model. Can that lead to overfitting or no?
No. More the number of models, lesser will be the chance of overfitting.
And in industry, overfitting is a bigger problem or underfitting? Like
Underfitting is Underfitting is always a bigger problem as compared to overfitting. See,
Okay.
overfitting is something that I have seen that the people are being easily able to reduce.
Okay.
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 But underfitting in general happens when you do not have good variables. The example that I take every time is when you are trying to predict height of someone. If
Yes.
you're trying to predict height of someone, and if you don't have the race of that person, if you don't have gender of that person, right, you will not be able to accurately predict the height of that person, irrespective of what variable you put, right? So
Yeah.
this model will definitely underfit. I can use a very advanced machine learning technique, but still cannot predict what is going to be the height of someone if you will not tell me the gender of that person, if you will not tell me the race of that person. Okay.
But
So in this case, the model will underfit. So a lot many times, the important variables that we need are missing. Okay. In those cases, the models will underfit, and you cannot solve that problem just by using advanced machine learning technique doing this and that. No, you need to bring those variables only. Only after that, you will be able to increase the accuracy.
so you get a data set and it's not, and you found that with any of the model you use, but you cannot, like, there is no no good accuracy. So then
Right.
you have to go to your data engineering team and say that the data you given is not good, right? Or how?
Right, right. So in general, what happens? It's not that straightforward. The data
Okay.
engineering team will ask you, okay, what do you want then? Maybe I have it, but you need to tell me, no? Right?
Okay.
I
Okay.
cannot give you everything. So in general, how it happens is that you need to have a good understanding of business, a problem statement, and then you ask yourself, like, without even going to data engineering team, you first ask yourself, what are the different variables which can help me in predicting this particular target variable? Okay. You create those list of variables first, and then you go to data engineering team. You cannot go to data engineering team saying that, okay, I'm solving some problem, give me all the data.
But is the data engineering thing, like, say you are we are collecting data from all the sources, and you data engineering team like clean it and give, like, will they tell everything about, like, the, like, say there are some columns maybe they have chopped it off, or, like, I'm just ask, I don't know, but I'm asking, like, will they give all the detail, like, which they chopped off or something, or
No. Actually, what happens is, see, right now you are assuming that there's going to be one person who will know everything,
yeah,
right? But
yeah,
that is not the case, right?
yeah,
What is going to happen is that when we say data engineering team, you are imagining it one person.
yeah,
But what happens is that data engineering team will be of 100, 200 people, right?
yes, yeah,
Everyone is working on a different thing, and everyone is working in silos.
yeah,
Okay.
yeah,
So a lot many times the people don't even know what the other person is working on. So maybe there is a data set available, but some other person is working on it. So I'm not aware of it. Right.
yeah,
So in general, what happens is they will simply ask you, what do you want? You tell me that, and then I will go around and check with my team, my seniors, my sister teams to see whether that data is being captured or not. Right. But
okay,
expecting that I will be knowing everything what is happening in the data engineering team, that is not correct. Like
okay,
that will not happen.
okay,
That's the reason the data engineering team might be capturing 5,000 different variables. But believe me, you will be able to get only 100 or 150 out of it. The
okay,
reason
and
being is those 5,000 variables are being worked upon by 200, 250 different people,
yeah.
right?
And you will not know also that the 5,000 variable name also, right? Like,
Yeah, no.
okay.
So there are thousands of different tables are there,
Yeah,
thousands of different variables are there. Data engineering team themselves don't know what they're doing, right?
okay.
Because what happens is that you're working on some variable, then you left the team, you joined some other company, so
Hmm.
someone stopped working on it. Like a lot of
Yeah,
things happen. Okay,
yeah, yeah. I got it.
so in general, the people don't know what is happening most of the time. But if you tell them that, okay, this is what I want, then they can go around and check and can tell you that, okay, whether this thing is available or not.
Mm. Okay. So
Pune.
from the problem statement, you have to be, you may make sense. Okay, this is not making out. Maybe something is missing. Then,
Hmm.
like, if you have business domain, or you can sit with some business analyst,
Hmm.
he may have some. Okay, maybe
Hmm.
this is data is missing, right? Like,
Yeah.
maybe as a team you can like decide what.
Yes.
Yeah. Okay.
Hmm.
Can I ask now?
Mm-hmm. Mm-hmm.
Like here we were talking about Guinea value.
Mm-hmm.
I read on Chat GPT about it. It
Mm-hmm.
is written Guinea is Guinea value and Guinea index is same.
Guinea index, I'm not sure, may or may
Because
not be
it is
same.
also written that it is also known as Guinea impurity.
Yeah, that I know. Yes. Guinea index, I'm not sure, but Guinea value, yeah, and impurity is same. Yes.
So, and also zero indicates perfect purity. All elements belong to a single class, and one indicates maximum impurity. This
Mm-hmm.
is not clear.
Mm-hmm. Mm-hmm. No, no, I don't think. I feel like it that Gini value, now based on what you have said, it feel like that the Gini value and Gini index are two different things. Because
Okay.
what you are saying is that the zero means impurity and one means purity. The Gini value is never zero. The minimum value is 0.5 in case of Gini. Okay. So I am assuming most probably based on what you have said that Gini index is nothing but a normalized version of Gini value. That Gini value is varying between 0 to 1 and Gini index must be varying between Gini value is varying between 0.5 to 1. And I'm assuming that the Gini index must be varying between 0 to 1.
Okay.
Okay. In case of Gini value, 0.5 means
Minimum.
it is impure and 1 means it is pure.
Okay.
Okay. Because if you remember, this was the graph that we had, right? This cup shaped graph that we had,
Yes.
right? Here the Gini value was 1. Here the Gini value was 1. This point belongs to p value of 0. This point belongs to p value of 1. What is p value of 0? P value of 0 means that everyone in this group do not play cricket. So it is a pure group, right?
Okay. Yes.
If no one is playing cricket in that group, that is a pure group. Similarly, a Gini value of 1 means that everyone plays cricket. That is also a pure group,
Yes.
right? So now if everyone plays cricket, that is also like a pure group. If no one plays cricket, that is also a pure group. But a 0.5 value means 50% people play cricket. That means 50% do not play cricket. And this will happen at a p value of 0.5 and the Gini value corresponding to this will be 0.5.
Okay.
Okay.
But you just search for Gini value in Google, that is saying that zero is pure and 1 is impure.
That is different.
Just 1
Yeah,
minute. 1
because
minute.
even I searched, it says
Mhm.
that if it is having a value of 0, the nodes
Mhm.
seem to be pure, that is, they belong to the same class, whatever samples we are checking. And if we
Mhm.
check for the value of 0.5, it means it is maximally impure.
Mhm.
So this is a little confusing, actually.
Mhm.
Uh,
Just 1 minute.
And also, the formula for calculating the weighted Gini is being given different. So it's 1 minus sigma of pi probability whole square. That pi
Yeah,
is the,
just 1 minute. I'm just checking the same thing. Just 1 minute. Just 1 minute. Okay, so there are I just read about it. So what you have done is you have simply searched Gini value, and that's why it is giving you the range of 0 and 1. So there are two types of, based on the internet that just I've just searched, there are two types of Gini values. One Gini value is used for finding the model performance. And the formula of this particular Gini value is 2 times AUC, that is area under the curve, minus 1. Okay. The other kind of Gini value that we have talked about is the one which is used for your tree splitting. Okay. The formula for this one is p square plus 1 minus p square. Okay. The range of this one is going to be, just let me check it because I am reading it for the first time. Just 1 minute. The range of this one is between 0 to 1. And range of this one is going to be 0.5 to 1. The next thing that they have written is that using this Gini, this Gini, we can calculate something called Gini impurity, which is nothing but 1 minus Gini, which is nothing but 1 minus, 1 minus p square plus 1 minus p square. Okay. So what is the range of this value?
0.
Sorry.
0.5 to 1.
0.5 to 1. So what is going to be the range of this value?
0 to 0.5.
Very nice, right? If this is having a range of 0.5 to 1, 1 minus this will have a range of 0 to 0.5. Okay. So wherever you are reading, if that Gini value has a range of 0 to 0.5, it means that they are talking about Gini impurity. Okay. If it has a range of 0.5 to 1, they are talking about the Gini value that, let's say, for example, we have discussed. If it is having a range of 0 to 1, the one that you were mentioning earlier, okay, then it is a different kind of Gini which is used to measure model performance that has a range of 0 to 1. Okay.
So having Gini impurity lesser value or higher value? I mean, which one is good?
So having Gini impurity.
So, range is 0 to 0.5, right? For Gini impurity. So the value of Gini impurity, say it is 0.
Right.
And what does it indicate? I mean, it's a pure split, right? So there
Right,
are
right.
no, I mean, not diabetes, not playing cricket. Those kind of values we don't have in a leaf node, right? So the Gini impurity value, if it is going down, that means we are splitting based on that, isn't it?
Yeah, right, right.
Okay.
Let's do it simple, right?
Yeah.
Gini value of 0, Gini impurity value of 0, is it a good thing or a bad thing? If I will ask you that. For a variable, is it an important variable when the Gini impurity value is 0? Or is it an important variable when the Gini value is, impurity value is 0.5?
0.
When
0,
it is
right?
0, it is important, yeah.
Yeah, it will be important. Why? Because it will be 0 only when this particular value is
1.
1. And when this particular value is going to be 1?
Then
When
For
P
what value?
is 1.
when P is either 1 or 0 for both the cases, right? For both the cases, for this case as well, for this case as well. Okay, so point being is either, see, using this, whatever we have over here, whatever the decision that you will take the same decision using this as well. Clear, not clear? Okay, any question on this? Right. First to clarify, when you're doing it, when you're trying to Google, you are getting confused because there are two types of Genie. Okay. So if you're making a Google, make sure that you're talking about, you're referring to the Genie which we use for split of tree nodes. Otherwise, by default, it is talking about this one. Okay, that is first thing. Second thing is when you will talk about the Genie that we use to split the tree nodes, okay, there also the people are talking about two Genies. One is the Genie value by default, this one, and other is the Genie impurity value. You can use this as well, you can use this as well. Both will give you exactly the same answer. Okay, when you are using this, the Genie value, in that case, higher the value, more important the variable is going to be. But obviously, if I will subtract this thing from 1, and then the lower the value, more important that variable is going to be. Cool.
Puneet, I have a question, not
Mhm.
related to this, but
Mhm.
like some days back you were telling, right? The main challenge we face in real time is getting the target variable. Now, like in our class, we are just getting the data.
Mhm.
We are just
Mhm.
getting the target variable. How it will be resolved in real time? Like,
Mhm.
you got
So,
my question, right?
yeah, I got your question, right? So that is actually a lot based on, there's something which comes usually with experience. I'm being very honest.
Okay.
Like, let me give you an example. Okay. So first of all, I'm assuming everyone, this topic is closed. Okay, I'm not gonna pick again after this discussion. Okay, is it closed?
Yes.
Okay, right. So to answer your question, Tejas, right? So when long back, when I started my career, I was working on this project for Lenskart, right? Now, with Lenskart came up with a problem statement that we have high number of cancellations and we want to reduce the cancel orders. Okay.
Okay.
Now, if someone would have asked me that question, that I have a high number of cancellations, I want to predict those cancellation and reduce those cancellation, what is going to be my target variable? What is going to be my target variable in that case? Yes.
Cancel yes or no, and probably how many times?
Like in general, we do it at a, let's
Yeah.
say, a row
Yeah.
level, right? So I will not say how many times. For each order, either it will get cancelled or it will not get cancelled, like 0, 1.
Yeah.
Right? If I will bring in how many times, the problem is then it will not remain 0 and 1. Right? So I
Yeah.
will simply do whether the order will get cancelled or it will not get cancelled. 0 and 1. Simple. Right? Now, because my manager had some experience, he said, no, this is not how we will define the target variable. Okay. If we will define the target variable this, maybe we will not get a very high accuracy because we are assuming all the cancelled orders are like same, but which is not the case.
Yeah.
What we should do is we should first try to understand why do people cancel orders, and then we will think about what should be my target variable. So he said, what we will be doing is that each cancel order, we will be dividing it into multiple parts. Let's say if a order get cancelled, then we will look at whether it is a true cancellation or it is a pseudo cancellation. Right? True cancellation means that you wanted to purchase, let's say, some sunglasses with me, right? You place the order, then because of some reason, let's say the order got delayed or you didn't like the product or XYZ reason, you cancel the product and you purchase it from someone else. That is a true cancellation because here I'm losing revenue, right? Because of let's say I'm not being able to deliver good quality product or I'm not being able to deliver fast enough. Okay. Second case is of pseudo cancellation. What is pseudo cancellation? Pseudo cancellation is, let's say, you placed an order for sunglasses, and then after 2 days, you realize that, okay, maybe this is not going to be a good fit. So you cancel that order, you place another order of some other sunglasses, and that I delivered, right? So in this case, if you look at it, it was not a loss of revenue for me,
Yeah.
right? You wanted to purchase a sunglass, you purchased the sunglasses, and you purchased it from me only, right? So you never had an intention of buying two sunglasses. So assuming that I lost a customer, that will not be correct, right? In this case, I will be losing a customer. In this case, I will not be losing a customer. Or let's say, think about it in another way also. Let's say from Myntra, right? We all of us, whenever we want one shirt, we order 3 shirts from Myntra. Okay. Then all 3 shirts will get delivered. We will try those out. If you'll see that, okay, this one is looking good at me. So I will keep that one and maybe return the other 2. Right. But does that mean that I had 3 intention of buying 3 shirts? No. I had only intention to buy 1 shirt only.
Okay, so that will be also coming under pseudo cancellation.
That
Or
will also be
breakthrough.
coming. Yeah, right. That will also come under pseudo cancellation. Right.
Okay.
Now the thing is that whenever we want to reduce cancellation, I want to understand what is the reason behind it. Okay. If you want to reduce cancellation because you feel that I'm losing customers because of that, or it is having a bad experience to the customer, then I should focus only on this one. Right? Because only this one is leading to bad customer experience. This is actually leading to good customer experience. Just imagine if I will start penalizing you for making multiple orders with Myntra. Okay. Will you order more frequently with me? The answer is no. Why? Because you know that, if I want to order 2 shirts from Myntra and want to keep one, the Myntra is going to penalize me. On the other hand, let's say if I'll order those 2 shirts from Amazon, right? And even if I don't like them, I can return them without any penalty. So in which case you will like the company more? Obviously in the second case, right? Where you are being able to return the product or cancel the order without any penalty, right? So in which case you are having good experience with the company? In the second case. So if my concern is that the customers are canceling the order because some XYZ reason, because they have negativity towards my company. By negative can be because of, let's say, I was trying to purchase, let's say, one fridge from Amazon in some great Indian sale because they were giving a 50% discount. After 2 days, I realized that the same fridge is, let's say, available at 60% discount on Flipkart without even any sale. So I will cancel my order with Amazon, right? But I will have a bad experience with the Amazon. Why? Because the same product was available somewhere else at a lesser price. So you made me cancel. I never wanted to. You made me cancel, right? On the other hand, just imagine I placed one order on Amazon. It was at a 50% discount, and later I realized that no, maybe this color fridge is not good. With in my home, let's say this red color fridge will go well. So I cancel the first one and I change the color of the fridge and I purchase something else. Will that lead to a bad experience or a good experience? Good experience, right? So depending upon why you want to reduce the cancellation, right? Based on that, I should decide what should be my target variable. Should my target variable will be these 2 combined or only the first one?
First one.
Right? So here, for example, is like this is the example that I'm discussing because at the very first thought that anyone will have is, it is a very simple problem.
Yeah.
Right? But when you start thinking from this perspective that why I'm solving it, okay, what is exactly I want to achieve out of this, then you start thinking about what should be my target variable, and maybe based on that discussion, your target variable might change, right? But this is a very specific example. If you look at it, I
Yeah.
can just tell you that, okay, this is how we should think. But what challenge that you might have at your work, that I cannot predict, that I cannot generalize.
Yeah. So what might be the other challenges in real time scenario, like apart from this output variable, a target variable?
Uh, in general, I believe that the most of the challenges are associated with we not understanding the problem statement correctly. Okay.
Okay.
Whenever someone gives you a problem statement, the first thing that the people start thinking about is which machine learning technique I should use, from where I will get the data, this and that, right? Like the people start focusing a lot on the how part, how this will be done. And that's why they end up in a lot of trouble later part of the project. Okay.
Okay.
Whenever you get a problem statement, our first focus should be on why. Okay. Don't think from this perspective, just because I'm asking that why this project needs to be done, that means that I'm resisting in doing this project. Okay. Because a lot of people think that if I will ask my manager that why I should be doing this thing, what is the need of doing this thing, it means that I'm kind of saying no to doing this project. Okay. So don't think in that way. Always ask why it needs to be done. And someone says that, okay, I'm doing it because of this XYZ reason, always question that, right? That why was the needs of it, this and that, from which meeting it is coming from. The more you will know why someone wants to do a project, more easily you will be able to complete that project without making any mistakes. Okay, because then you know what needs to be done. And this thing only, the cancelled or example that I have taken, anyone with little bit of a common sense, if you start putting it there, and obviously it's just not about the common sense also. Uh, in the starting, you need some guidance. Like with me, let's say, for example, my manager was there, later my team was there, right? So you always brainstorm. Don't imagine yourself as an individual on the project. There will always be a lot of people who will be helping you, at least for the first 6 months, right? And by that time, if you'll keep your eyes and ear open, you will be able to learn what needs to be done. Okay.
And Puneet, from this example,
Hmm.
what are the target variables?
The cancellation example.
Yeah.
Yeah, there, let's say, for example, true cancellations can be my target variable.
Okay.
Okay, let's go back to our AdaBoost. Okay, so we were discussing that in case of AdaBoost, we will be taking only one variable at a time and we will be creating stumps, right? Now, to create stump, let's say this is what my target variable is, whether someone will have heart disease or not. This is what my target variable is. And what are my input variables? My input variable is whether you have chest pain or not, whether you have blocked arteries or not, and what is the patient weight. Okay. Now, using these variables, I want to predict whether someone will have heart disease or not. Because in case of boosting, we create stump. That is, we take only one variable. So what I will do is, I will see that which variable is giving me the highest accuracy. Which variable is giving me the highest accuracy? I will check chest pain. Okay. Let's say, for example, here I'm checking chest pain. If someone is having chest pain, how many people have chest pain? 1, 2, 3, 4, 5. 5 people have chest pain, right? So this bucket is of 5 people. Out of these 5 people, I can either give them, yes, they have heart disease, or I can give them, no, they do not have heart disease. These are the only two options that I have. So what will you classify it as? Okay, so I have 5 data points. I will repeat it. I have 5 data points. This data point, this data point, this data point, this data point, this data point. For these 5 data points, in some cases, I have a heart disease. Yes, yes, yes. In some cases, I do not have a heart disease. Let's say this and this. Now, to these 5 people, I can only either give yes or I can give no. So what will be your prediction for these 5 cases? Yes, they have heart disease or they do not have heart disease.
I'll go with it. Yes,
Yes. And why we will go with yes?
because 3 out of 5, like
Exactly.
60%.
Right? Because majority of the people in this group, the one that I have highlighted, is having heart disease. Okay. So if I want to increase my accuracy, I need to say all of these 5 will have heart disease. If I will do that, how many correct and how many incorrect classification I will make?
3 correct and 2 incorrect.
3 correct and 2 incorrect, right? This is what they are saying. That if you have heart disease, then you will have 3 correct and 2 incorrect decisions. Right? Now, similarly, I will mark not having heart disease. Oh, sorry, not having chest pain. These 3 do not have chest pain. And corresponding to these 3, this person also is not having heart disease, not having heart disease. One person is having heart disease. So what should be my prediction for this group?
No.
No, right? That no, they do not have heart disease. And how many correct and how many incorrect classification I will be able to make?
2 correct and 1 incorrect.
Two correct and 1 incorrect. So 2 correct and 1 incorrect. Okay. And now what is going to be my total accuracy? If I will use chest pain as a classifier.
66% plus 60% divided to.
Simple, we can do. How many correct classification I have made divided by total number of classification. So how many correct classification I have made?
5 by 8.
5 by 8, right?
5 by 8.
0.5125.
Right. Something for now. Okay. Now, similarly, what I will do is I will check for blocked artery as well, whether you have blocked arteries or not. How many people have blocked arteries? 1, 2, 3, 4, 5, 6. Corresponding to this, how many people have? These people do not have heart disease. These people do have heart disease. So what should I do in this case? Should I classify it as having heart disease or not having heart disease?
It's 50-50. You can.
We can take actually any, right? In any case, Alonia, can you please go on mute? Okay. So, we have heart disease versus we are not having heart disease. Both have like equal count. So irrespective of what we make as a final prediction, we will have 3 correct and 3 incorrect. Okay, 3 correct, 3 incorrect. That's why 3 correct, 3 incorrect. Now, let's see how many people are not having blocked arteries. No, no. In this also, unfortunately, we have 50-50. So again, you can either predict as heart disease or you can predict not heart disease. In both the cases, okay, you will have 50% correct. So what is going to be my accuracy?
50%.
50%.
50%, right?
So this node will have less priority, right?
Yes, this node will have less priority as compared to the previous one.
Okay.
Okay, as compared to 5 by 8, the 4 by 8 will, this variable will have less priority. Now, let's talk about the weight of the patient. Let's say we have taken greater than 176 and less than 176. If it is greater than 176, how many rows we have? This is greater than 176, 176, right? Now, for these, all of these, I have heart disease. So what should be my prediction for these three?
Have
That
a
yes.
100% accuracy.
Right, right. So we will say that, okay, yes, these people have heart disease. That will be my prediction. Similarly, wherever the weight is less, what should be my prediction?
80%.
Right.
not having
My
a-
prediction, not having a heart disease, right? And that's why my accuracy is going to be total
7 by 8.
7 by 8,
7 by 8.
right? So out of the 3 variables that I have, which variable I will be using first?
Wait.
Wait.
Weight, right? Exactly. So my first variable is going to be weight. That is the first model that we have created. Why I'm calling it a model? Because in case of AdaBoost, only stumps are taken as models. Okay, only one variable is taken at a time. So this is a model. This decision tree that we have just created, this is a model. That is going to be our first model. Using this model, okay, so now for each model, I need to do 2 things. Okay, for each model, I need to do 2 things. First thing that I need to do is I need to calculate his weightage. I need to calculate the weightage of the model, or what we call it as amount of say. Right? What is the second thing that we need from a model? Second thing that we need from a model is how this model will pass its learning to next model. You remember, in case of boosting, how the models are created? In series or parallel?
Series.
Series.
In
the
series,
output
we
is given to another.
right,
It's
right. Exactly, right? In case of boosting, the models are created in series. Because the model are created in series, why the model are created in series? Because the output from one model is used as an input for another model. So how do we do that? That's something that we need to discuss. And we also need to discuss that in case of boosting, each model has a different say depending upon the model accuracy. Okay, so we need to find out how we calculate the weight of the model as well. Okay, so both the things will say. So first thing is amount of say. This one. This is the formula. This is the formula. 1 by 2 log of 1 minus total error divided by total error. What is 1 minus total error?
Accuracy.
Accuracy. Very nice, right? So this is ln of accuracy divided by error. Okay. Can you guys create the graph of this particular thing? Right? Either this or this, whatever you feel comfortable. Using ChatGPT, try to create a graph of this and see how the graph will look like. Okay, ask ChatGPT to create a graph of this.
Along with the LN, log,
Along with what? Sorry.
the
along
whole
with
formula or only accuracy by error?
No, the whole formula.
Okay.
We create the graph, see how the graph is looking like.
Horizontal is.
Punit, I
Sorry.
can't see your screen. It's showing like the screen sharing is paused.
Mm-hmm.
Can you please reshare?
No, it's visible.
Yeah, now it's visible.
No, it will be paused, but the screen that I have paused, that was visible, right?
Yeah, it's visible now.
Mm-hmm.
It's looking like that S curve, Puneet.
Like opposite to S curve.
Okay. Something like this.
Yes.
Right? Something like this we are being able to see. So the amount of say with respect to total error, this is how it will look like. Okay. Now, can you guys tell me what are your observations? What are your observations from this? Okay, ask ChatGPT only because you have already created the chart there. First, take a moment to understand it, to observe it yourself, and then ask ChatGPT what are the key observations from this chart. Let's see if you are being able to observe everything or not, or can ChatGPT give you more observations?
Oh, what is here in the y-axis here? Total error is in x.
Sorry, the total error is nothing but the 1 minus accuracy of that model.
Now, what is in the y-axis? Like I'm saying.
Y-axis is nothing but the amount of say. This thing, the weightage of the model.
So amount of say is very high when error is low, right?
The amount of say, very nice, very nice. Amount of say is going to be high when the error is low. What's next? That is a good observation.
Threshold is greater than less than 5.5 error. So amount of yes are
When
positive.
Mm-hmm.
And if it is greater than 0.5, the sprays are negative.
Very nice, Vinay. So, okay, so Vinay has made a good point that when the total error is less than 0.5, then the amount of say is positive. When the total error is greater than 0.5, then the amount of say is negative. Can you build on top of this comment that the Vinay has made? What is the meaning of this now? Why it might be happening?
I mean, what when I just made the point, and in addition to that, like total error. If we are getting total error, which automatically means the model accuracy is less. So ultimately, if the model accuracy is less, so why we would give that model the weightage in the ultimate model? So when the accuracy is more or the total error is less than 0.5, so we will give that model more weightage and vice versa.
Okay, nice. Okay, let me give you a scenario actually. Okay, so these days everyone is trading or investing in stock market, right? And a lot of people follow a lot of different gurus as well, right? That the people who give tips, XYZ other things, right? Now let's imagine that there are two people who are this market guru. One is Ishan. Okay, another one is Vinay. Okay, now let's imagine that Ishan is like very super intelligent. He has spent like years in stock market, and he whatever the stock recommendation that he gives, whatever the stock recommendation that Ishan gives has a 80% accuracy. Okay, and for this, because he is giving very accurate recommendation, Ishan is gonna charge definitely high, so he is gonna charge you 2 lakh per year. Okay. On the other hand, let's say Vinay is a newbie. He also gives stock recommendation. Okay. Vinay is having 10% accuracy. And Vinay is charging, let's say, 10,000 rupees per year. Whose recommendations you will choose? For whose recommendation will you pay? Ishan or Vinay?
Ishan.
Ishan? Anyone who will pick Vinay? Everyone will choose Ishan, right? Because you will pay him 2 lakh rupees a year and his recommendation are 80% accurate, right? But I'm saying that if you will ask me this question, I will always be choosing Vinay. Now tell me why.
Based on the budget I have.
Yeah, based on the budget, but budget is not the only thing, right? Let's say, for example, um, uh,
Because if I pay 10,000 per year, at least 10% accurate, right? So, so
so will you end up losing more money or gaining more money?
gaining.
If you are accurate only 10% of the time, if you're putting money in your market and you are correct only 10% of the time, will you earn more money or lose more money?
Lose more.
Lose more, right? So why I will be preferring Vinay over Isha?
We'll do opposite of that. Like,
Right. Very nice, right? So whatever Vinay is saying, if I will do opposite of that, what is going to be my accuracy?
90.
90%, right? All I have to do is whatever is Vinay is recommending, do exactly opposite of that. So in that way, I will have a 90% accurate model for just 10,000 rupees a year. Understood? Right? So it means that a model which is very, very bad is also a very, very good model, given that you do exactly opposite of what that model says. Understood or not?
Yes.
Everyone is clear on this?
Yes.
Right. So Vinay is actually more important or more accurate as compared to Ishan, given that you do exactly what opposite of what Vinay is saying. Now look at this graph again and think about what Vinay was saying earlier. That when the accuracy is less, when the error is less than 50%, my amount of say is positive. But when the error is more than 50%, my amount of say is negative. Now, now look at the graph. Is it making more sense now?
Yes, yes.
What does the amount of say in negative means?
Amount of say negative means that whatever the the model will say, if model will say that yes, this person is having heart disease, and if amount of say is negative, then I will do exactly opposite of what the model is saying. Okay, if model is saying that yes, this person will have heart disease, I will predict no, this person is not going to have heart disease, and so on.
Okay, so here in this case, if error is 1 and amount of say is -3, then what does that mean?
Can you repeat that?
No, in this case, if total error is 1.0, means it is amount of say is -3, right? So what does that mean?
Where the total error is 1.0.
No, in that graph only. In that graph only.
In that graph only. Okay, the like
ending
first of
tip is there. Ending tip is there. Tip is at 1.0 total error, right?
here, yeah, this one.
This one, other end. 1.0.
This one. Oh, 1.0. Okay, that is
Right,
one. Right. So in general, we will not talk about the extreme edges, because what is happening is that at the extreme edges, it will gonna reach infinity. Right? Why it is reaching infinity is because just imagine if you are being able to create a model which is 100% accurate. Hypothetically, just imagine if you are being able to create a model which is 100% accurate. First of all, it is not possible, right? Given that a lot of data points that we have, but even if there is a model, do you need multiple models after that?
No.
Right? Let's say, for example, if I need to give a first class exam where addition is coming, like 1 + 1, 3 + 4, 9 + 8, 7 + 2, these kind of questions are gonna come. Will it be wise for me to bring 4 or 5 different other people as well just to attempt that paper? No. Right? If there is someone who can give you the 100% accurate answer, then you don't need a lot of model. Just that model is enough. Right? So first of all, that does not happen. But if that will happen, my amount of say will reach infinity. It means that only keep that model, whatever other models are saying does not matter. Okay. Same on the other hand as well. If a model is always wrong, that model is also very important. If a model is always wrong, then my value will reach minus infinity. Okay, the value will reach minus infinity. What is the meaning of that? The meaning of that is that if a model is always wrong, then what I need to do is just do opposite of what that model is saying, and I will get 100% accurate model.
But in a real scenario, will that kind of models exist, which will say all bad?
No, nothing.
All right, yeah.
No, right. So max to max, let's say we will have 0.9, right? 0.9 also will have somewhere around -1. Okay.
0.9 error means it is -1. That means
-1.
That means what does it say -1 in the sense?
So the meaning of that is that model is equivalent to having a model of 90% accuracy. So for example, even if I will look at error of 0.1, error of 0.1 means what is the accuracy?
10%.
No. Error is 10%. So accuracy is going to be
90%.
90%. So for a 10% error, my amount of say is 1. That if this person will cast vote, that vote will be counted as 1. On the other hand, if there is, let's say, a 90% error a model is having, that model is also equivalent to 90% accurate model. It's just that I need to do opposite of what that model is saying. That's why the amount of say is -1. Do opposite of, like, whatever the vote that you will cast, I will flip it and give it a weightage of 1.
So it will be like parabola for this case. We'll be just doing the opposite of this. Yeah.
Any question on this? Clear?
Yes.
Okay. Now, so we have discussed already amount of say. Okay. What is left? What left is how this model is going to pass its learning to the next model. Okay. So let's talk about that. As of now, the weightage of each row is 1 by 8. Right? Why it is 1 by 8? Because there are total number of 8 rows are there. And all rows are equally important to me. So each row has a weightage of 1 by 8. Clear? Total number of 8 rows are there. Each row is equally important for me. The weightage is 1 by 8. So when the first person is going to attempt the exam, he is assuming all the topics are equally important. Okay. Now what is going to happen is the first model is making a mistake. Where the first model is making the mistake? The first model is making the mistake here. For this particular row. Why? Because in this case, the weight is less than 176. Less than 176. But so my prediction is going to be what? If my weight is less than 176, what is going to be my prediction?
No.
That no, you do not have heart disease. But what is the actual value?
Yes.
Yes. So this is the error. Right? Because here I am making an error. What I'm going to do is I'm going to increase the weightage of this particular row. Okay. I'm going to increase the weightage of this particular row so that when the next model will be coming, I will be telling that model that give more importance to this particular row. I will not tell that whether the answer is yes or the answer is no. I will just say, just be extra cautious about this particular row because this is the row where I have made the mistake. How the model is going to tell that? By increasing the weightage of this particular row. Okay. How do we calculate the new weightage? Okay. New weightage is calculated using this. Okay. This is how we will calculate the new weightage. New weightage will be equal to, new weight will be equal to the old weight. Old weight was what? 1 by 8 multiplied by e raised to power amount of say. Okay. For the previous case, the amount of say was 0.97. How we got the value of 0.97? Let's see. For the previous case, the amount of say was 0.97. Why? Because amount of say is nothing but 1 by 2 ln of 1 minus error divided by error. 1 by 2 ln of, what was my error?
1 by 8.
1 by 8. Right? Divided by 1 by 8. Okay. So 1 by 2 ln of 1 minus 1 by 8 will be nothing but 7 by 8.
1 by 8 upon 1 by 8.
Divided by 1 by 8. This will become 1 by 2 ln of 7.
That 1 by 8 is like one incorrectly classified point, right?
Yes.
Oh.
Okay. So it will become 1 by 2 ln of 7. So 1 by 2 ln of 7 is nothing but 0.97. So it means that this model will have an amount of say 0.97. That is, if this model will cast a vote, that vote will be counted as 0.97. Okay. Now when I want to calculate the new weightage of each row, when I want to calculate the new weightage of each row, what I need to do is 1 by 8 multiply by e raised to power amount of say, that is 0.97. This will give me the new weightage of the row. Okay, old weightage multiply by e raised to power amount of say.
How is total error is 1 by 8 here in calculation?
The accuracy was 7 by 8, right? So error is going to be 1 by 8.
Okay, yes.
Okay. So the new weight is coming out to be 0.33. The new weight is coming out to be 0.33. So this weight, earlier this weight was 1 by 8, new weight is 0.33. Have I increased the weight or reduced the weight? What is the value of 1 by 8?
Increase the weight.
0.125.
0.125. This was the old weight. What is the new weight? 0.33. So have I increased the weight or decreased it?
Increased.
Increased it. Okay. Earlier it was 0.125. Now it is 0.33. For other values, I will also adjust the weight where the value was accurate. Where the value is accurate, I'm going to tell my next model that these questions are easy. So you can take it lightly. Okay. So to do that, the same thing. Old weight multiply by e raised to power minus amount of say. Last time it was plus amount of say. This time minus amount of say. So this is going to do what? It is going to reduce the weight of the existing rows. 0.05. Okay, so this is 0.03, and wherever I have made the right prediction, it is going to be 0.05. It is going to be 0.05. What was the earlier weight for all the rows?
0.5.
1 to 5. So in this case, have I increased or decreased it?
Decreased.
Decreased.
So I have decreased the weight wherever I have made the right prediction. I have increased the weight where I have made the wrong prediction. And again, I have decreased the weight. Okay, so wherever I have made the right prediction, I have decreased the weight. Wherever I have made the wrong prediction, I have increased the weight. But now there is a problem. Earlier, when the weight was 1 by 8 everywhere, what was the total weight if you will add everything up?
1.
1, right? Now, what is going to be the total weight? Earlier, the total weight was multiplied by 8, 1. Now, the total weight is
0.68.
right, 0.05 multiplied by 7 plus 0.33. So it will be 0.35 plus 0.33 is going to be 0.68. Earlier, the weight was adding up to 1. Now it is not adding up to 1. Right? Ideally, the weight should of all the rows should add up to 1. So what I will do is I will normalize. How will I normalize? I will just divide each weight by 0.68. So I will divide 0.05 everywhere by 0.68. Similarly, I will also divide 0.33 by 0.68. This will come out to be 0.07. This will come out to be 0.49.
From where you got 0.68?
By adding all the values like these 0.5 plus 0.05 plus 0.05 plus 0.33. If you add all these values up, you will get 0.68. Okay.
Puneet,
Mhm.
how did we get to this number 0.05 after adjusting the weight of the data points which were already correct?
Right, yes. By using this formula, right? Sample weight multiplied by e raised to power amount of say.
Okay. And how did we the data point which was incorrect? How did we increase this value?
The same thing is just that instead of minus, we had plus here.
Okay, okay.
Same formula, just plus. Okay, now what we have done is we have normalized the weights. Okay, so let's take a break here and then we'll connect at 11 again and we will discuss it further. Is it fine?
Okay.
Yes.
Cool. I'll keep sharing the screen in case you want to refer to, but we'll connect with you at 11 now. Okay, we'll start in 30 seconds.
How you got 0.05?
By that formula where 1 by 2
Okay.
old weight, right? E raised to power minus amount of say.
And plus is giving 0.33, right?
Yes.
Okay.
Okay. Let's start. So what we have done next is we have just normalized the weights. By normalization, we mean that we just divided like the summation of this. The summation of this was 0.68. So we divided 0.05 by 0.68, 0.33 by 0.68, and it gives us weight, new weight for each row. Okay. This weight concept we also discussed at the time of which machine learning technique? Logistic regression, right? If you remember, in logistic regression, we also talked about weights. And there I said weights mean nothing but duplication. Okay.
Yes.
More the weight, more is going to be the duplication. So now you can just imagine as if, let's say, each row, right? More or less, you can imagine that this row is getting repeated 7 times. This row is getting repeated 7 times. This row is getting repeated 7 times. This row is getting repeated 49 times. This row 7 times, 7 times, 7 times, 7 times. This is how you can imagine it. Okay. So now if you will make a mistake over here for this particular row, it will get penalized 7 times more as compared to if you'll make a mistake in any other row. Okay. So this time again, I will try to find which variable is going to give me high accuracy, but the accuracy will be calculated in a little different way. If you'll make a mistake here, I will penalize you 7 times more as compared to if you'll make a mistake somewhere else. Okay. And based on this, again, I will check all the 3 variables. I will check chest pain. I will check blocked arteries. I will check patient weight. And I will see which of these variables is going to give me the highest accuracy. And that variable will become my second model. Okay. That variable will become my second model. Okay. Here they're explaining the same thing. That the duplication thing that I was talking about in these slides, it is explaining exactly the same thing. That I will be duplicating the rows. So duplicating the rows is same as increasing the weights. Okay. Now, once you have duplicated, you will again check whether chest pain, blocked artery, or patient weight is giving you the highest accuracy, and that is the way that is the variable that you will be using. Sorry, that is the variable that you will be using to create the new model, and so on. We will keep on repeating this till let's say till 10 number of times, 20 number of times, or 100 number of times. Totally depends upon you. Right? Now, let's say we have multiple models. We have created, hypothetically, we have created 6 models. Okay. We have model 1. This is my model 1. This is model 2. This is model 3, model 4, model 5, and model 6. Now, a few models will say that yes, the person has heart disease. And we are talking about one patient at a time. So I have taken one row And these 4 models are saying that yes, patient has heart disease. And these 2 models are saying that no, the patient do not have heart disease. Okay. Of all the models which are saying that the patient has heart disease, I will add their weights. I'll say that, okay, 0.97 plus 0.32 plus 0.78 plus 0.63. That is my total number of votes in the favor of yes. Similarly, in the favor of no, how many votes I have? 0.41 plus 0.82. Okay, so here I have 2.6 votes in the favor of yes. In the favor of no, I have 1.23 votes. So my prediction for this particular patient is going to be yes, this person has heart disease. Clear?
So, one question, like, can you go back to the slide where we have done the, I mean, where we have created the second model?
Where we have created the second model, okay?
Second model in the sense, like, we passed
Wait.
that, yeah, wait. Yeah.
Let's say here, yes.
Yeah, so here, do we select all the records from the model one?
Yes, all the records for the model one.
In the random tree, we did the sampling, I mean, random sampling. Here we don't do it, right?
Yeah,
We
here
have
we
to
don't do
select
it.
all.
Yeah,
Okay.
exactly. Yes. Because there what we were doing is, actually very good question, Sumit, right? So there I said that if I will use the same data set and same modeling technique, I will get the same model, right?
Yep.
So what I can do is, I'm using the same modeling technique, but I need to use a different data every time to get a different model. How do we get a different data every time? By doing bootstrap sampling.
Yeah.
You remember we did bootstrap sampling with replacement. Right?
Yes.
So every time we were taking 70-80% of the data, but that 70-80% data was always random. So because I'm taking 70-80% of the rows every time, so I will get a different set of rows, different combination of rows every time. So the data set will be different every time. Okay. That will result into different model every time, slightly different model, not drastically different, slightly different models. Here, if you look at it, I'm using the same modeling technique. What is the modeling technique? Decision tree. I'm using the same data set every time. But why I'm getting different rows? Oh, sorry, different models every time?
Weightage
Because
of the weightage. Nice. Right? Because of the weightage. So I'm changing the weightage. By changing the weightage of the row, you are actually creating a different data set. Because weightage is like duplication. When you duplicate the data set in different proportions, then you will create a different kind of a data set.
So when the weightage is 7 times more, so in the second model, the number of records will be, 49 plus the rest of the things, right? 49
Yes.
records for that.
Yeah, it will add up to 100. Yes. Yes. You're right. So see, the accuracy is nothing. Accuracy is nothing. It's a ratio. Okay. So even then, even if I'm duplicating, it's not going to have a lot of impact on the accuracy. Right? Just imagine, let's say if you had 10 rows, if you had 10 rows, out of which one was incorrectly classified and 9 was correctly classified. So what is going to be my accuracy here?
90%.
9 by 10, that is 90%, right? Just imagine I have duplicated all the rows in the same proportion. So now I will have 100 rows, out of which 10 will get incorrectly classified, 90 will get correctly classified. What is going to be my accuracy?
90%.
90%, right? So don't think that the duplication is going to have any impact on the accuracy as long as the duplication that you are doing is in a different proportion. If you will do the same proportion, if you will increase all the rows in the same proportion, then the accuracy will not change. But if I will increase the rows in a different proportions, then the accuracy will change. Okay.
So till what point we are going to do this? Because somewhere we'll be getting it close to zeros, right?
Right. Actually, may or may not get close to zero, but for how long we should do it totally depends upon you. In general, more the number of time you repeat the process, the better it is. Okay. But in general, 20-30 times is more than enough. Let's say here, because I have only 3 variables, I believe doing it max to max 9 or 10 times is enough.
Okay.
Okay.
And one more question, like here we are doing it for decision trees, like all the models are decision tree. Like in some scenario can we do, what I mean is like I'll have different models, may not be decision tree, K means something something. So can we do that combination of this boosting on that particular type of scenarios?
Theoretically, yes, but practically we don't do it.
Okay.
Like theoretically, yes, we can combine different models together to make a strong model, but in general, it has been seen that decision trees works the best, and that's why in all the ensemble modeling techniques, you will see that the base model will always be decision tree. Right?
Okay.
But theoretically, yes, why not? We can use other models as well, but practically, it has been seen that for the same algorithm, if you will use decision tree, those are in general more accurate.
Okay. What will help me to determine which model to use for the data? Like,
Very good question, but the answer is very simple, hit and try. Okay. There is no way in which anyone can tell you beforehand, just by looking at the data, that this model will work the best. Okay. Yes, the probability of few models giving you high accuracy is comparatively higher. For example, AdaBoost will always have a high probability of giving you more accuracy as compared to a decision tree or as compared to a random forest, right? So if I have small data set, if I know that runtime is not a problem, and if the first modeling technique that I would like to try is maybe AdaBoost. Okay.
Okay.
Because AdaBoost in general gives you high accuracy as compared to anything else. But if someone will say that, no, I want to visualize the results that I have, then I will say that, yes, I will be using decision trees.
Okay.
So I have, referred like some articles, where they say we should perform the modeling on the base models. Like, for example, if you are doing any linear regression, then, do for the linear regression. So on top of that, use some advanced version of it. Then on top of that, use that gradient CV. They are asking us to go step by step.
Yes, yes. Yeah, that is actually a
So,
nice approach, because what happens is that why we are going from simple to complex approaches. In simple approach, it is easy to understand what is happening, which variable is working, which variable is not working out, how can I tweak it. All of that is like, because the algorithm is simple, you using your brain and tweaking the data set or the target variable, doing XYZ things is comparatively easy. As we go from simple to more complex model is equivalent to that you cannot do anything on your own. Everything will happen in the backend. Like, just take an example of deep learning for it, right? I can do a lot of tweaking with random forest, but deep learning, I cannot do a lot of tweaking. Whatever will happen in the backend. Okay, it will just give you that this is the final answer, but how it is reaching to the final answer, that it will not give you. So doing it step by steps helps us in understanding what is happening in the in our data set or in our modeling exercise.
Like, can you tell that like step by step, in the sense for like till some point we are using one particular model and after that we are moving to some other model? Is it
Not like that. Like, for example, if I want to solve any problem, in general, I would like to start with decision tree. Why I would like to start with decision tree? Because decision trees are very easy to visualize. You will
Okay.
be able to see which variable is coming on top. Okay, let's say gender is coming on top. If gender is male, then which variable is more important, and all of those things. And then by visualizing it, you can see that whether it is making sense to you or not.
Yeah, got it.
Right?
So based
But
on that and I mean the percentage of accuracy, I'll be moving to some other model.
exactly, right.
Okay.
You will also get some idea that which variable I should keep, which variable I should not keep. For example, AdaBoost in general takes more time to run as compared to decision tree.
Okay.
Right? If using decision tree, I can see that, okay, these are the 5 or 10 different variables which are important. So maybe the first iteration, instead of running it on all the variables, I will run it only on those 10 variables. Using those 10 variables, I will quickly get to see what is the accuracy that I'm getting. Maybe let's say hypothetically you got 80% accuracy. So I know that, okay, using these 10 variables, I'm getting 80% accuracy. I will check everything is fine or not. And then I will put all the 500 variables and then run it. Why I'm not putting all the 500 variables at once? The reason being is all the 500 variables, if I'll put it at once and the model is taking 3 days to run. After getting the result, after 3 days, you realize that, oh, I forgot that, I should have done some XYZ, but I have done some ABC. Now the next iteration will again take 3 days, right? So instead of that, what I can do is I can iterate more on a small data set with less number of variables. And once I have finalized that, okay, this is a modeling technique that I want to use. I have checked that all my variables are making sense. My target variable is making sense. Everything is making sense. All I want to do just now is to increase the accuracy. What I will do is, instead of putting 10 variables, I'll put 50 variables or 500 variables, and I put the iteration uh, for 3 days or 2 days, whatever it's going to take.
Will that not change the model
No,
accuracy?
it will just improve the model, right? See,
Yeah.
I don't have problem with model changing. I have the problem with model being incorrect.
Okay.
Okay.
So you're saying decision tree,
Which model performs better?
Which model
Yeah,
perform
I
better
mean,
means?
which model performs better? Is it AdaBoost or random forest, or does it depend again on the scenario,
It
on the
depends upon the
data set?
scenario, but most of the time boosting is more accurate as compared to bagging. But bagging will be faster as
Okay.
compared to boosting.
So
Okay.
in what
So
scenarios we'll be using that random forest apart from the
let's say,
runtime, real time? In what scenarios we'll be using that majority vote and
yeah.
bagging random forest?
Yeah, actually, random forest is very popular to find the importance of variables as well. Okay.
Okay.
As an output of random forest, you can get what is the importance of each variable. And the other thing is that random forest is also very immune to missing values and outliers.
Okay.
So if I have not, let's say I have a data set, I don't want to do the first step is in general what? Doing missing value treatment, outlier treatment, and all of that, right? Which takes time. If you have 300, 400 variables, missing value treatment and outlier treatment takes time, right? Now I don't want to do that.
Yeah.
I want to maybe, like, before spending time over there, I want to see that, okay, if I will use these variables, approximately how much is the accuracy that I can expect. So now I cannot use logistic regression because logistic regression is impacted by your outliers and missing value treatment. Okay. But random forest is not. Similarly, so in that case, what I will do is I will just simply run the first iteration using the random forest, because it says dump anything that you want and I will figure it out.
Why random forest is not impacted with the missing values?
Because see, what we are doing is we are creating buckets, right? So anything which is missing, it is going to create a separate bucket for it. That's as simple as so. It is going to kind of exclude it.
That means it will remove that variable.
Not remove it, it will put it into a different bucket.
Okay.
Okay, removing would have been that it is not part of the model itself, right? Bucketing it separately means that it's more of a less like this, that I'm trying to predict a height and I'm saying that wherever the gender is male, wherever the gender is male, the height is 5 feet 8 inch. Where the gender is female, the height is 5 feet 4 inch. Okay. If I have gender missing, I have null values for gender, my logistic regression will not run. It will give you error. Okay. But if I'm doing random forest, what random forest is saying, if you have gender male, 5.8. If you have female, then 5.4. If it is missing, 5.6 inch. Okay. So this is how random forest works. Random forest will give it a different bucket. But logistic regression will simply say that I cannot do this because there is a missing value and I don't know how to deal with the missing value. Why? Logistic regression does not know how to deal with the missing value because logistic regression works on an equation. Right? In an equation, if there is a missing value, you don't know how to deal with it.
Okay.
And how it will handle the outlier?
Again, a separate bucket altogether.
So it will be a distant leaf node, like in the corner. If say someone height is very like say 8 feet and say male or female.
No, actually, yeah, actually, this height was a bad example comparatively. The reason being is it is a continuous one.
Yeah,
right?
okay.
In general, random forest decision trees are for use for categorical one. Okay. So when we have categorical, so when I'm talking about height, let's imagine, like when you talk about outliers, you're talking about outliers in a variable.
Yeah.
Right. So let's say using height, I'm trying to predict whether you can go into army or not. Right.
Okay.
If I'm trying to predict whether someone will be easily get into army or not, and I'm using height as a variable. So what we will have is if your height is greater than equal to 178, then there's a high probability that you will get selected. When the height is less than 178, then there is a low probability that you will get selected for army. Right? Now, when I'm dividing the data in this way, then everything above 178 is a one bucket, irrespective of your height is 200, 210, or 300. Does not matter.
Okay.
Right? This is how it is dealing with the outlier.
So when you say in the bucket, right? So random forest, it does the bucketing part on its own, like inbuilt.
Yes.
Okay.
Yes. You need not to do it yourself.
So 130 to 160 will be in a one bucket, then 160 to 190 in another. That way?
Yes. In general, it creates two buckets. So there will be only one threshold above and below of that.
Okay.
Right? Because we have two, like if you must have seen, right? We have just only two buckets everywhere. So I cannot have multiple buckets.
Okay. And also, like, I mean, it handles outliers in a better way, the random forest, because, because of its randomness of the sampling, right? In AdaBoost, we don't have that random sampling. We always select the all records with more weightage. Is my understanding right?
Yes, your understanding is right.
Okay.
So, like in real cases, we will be having many missing values, right? Forget about outliers, but in real-time scenario, we'll have a lot of missing values. So we'll be tilting towards random forest compared to AdaBoosting.
If you want to get the first model done, yes, then I will be doing
First model?
random forest, right? Obviously, but eventually you want to treat missing values and then do any modeling technique that you want. It can be random forest, it can be AdaBoost. But I want to do missing value treatment eventually. But let's say if that is not the first thing that you want to do, then you can use random forest.
Can you please repeat? I didn't get it.
Right. I was saying that if missing value treatment in general is the first step, right?
Okay.
Missing value treatment and outlier treatment is the first step that we should do. But hypothetically, just imagine for a moment that I don't want to do missing value treatment and outlier treatment as a first step. The reason being is it is a time-consuming process. And let's say I'm a little eager to know what is going to be my minimum accuracy. Okay. In that case, I can simply take the data set, dump it into random forest and see what is the accuracy that I'm getting. Let's say I got 70-80%. I thought, okay, it looks fine. Now I know that if I will make my data set better by doing missing value treatment, by doing outlier treatment, I can get better accuracy than this, right? So that will give me a little boost about that, okay, in which direction I'm going. But just imagine, let's say I have taken the data set, dumped it into, without doing any missing value treatment, dumped it into random forest and I got 55% accuracy. Now I know that my first concern is not doing missing value treatment or outlier treatment, because even after doing that, 55% will become 60%, right? So my main concern right now is to again go back and see that which other variables that I can bring, which can improve my accuracy. You got my point?
Yeah.
Right? So in the case where you have got a data set, you dumped it into random forest and you got like 80% accuracy. Now I know that without doing any missing value treatment, outlier treatment, I'm getting 80% accuracy. It means that if I will do missing value treatment and outlier treatment, my model accuracy will improve further. From 80%, let's say it will go 85%, and I'm very happy. Okay. The second scenario is you got a data set, you dumped into random forest, and you got 55% accuracy. Now
Which
I know
means
that
you
even if I
said,
will go back, do a missing value treatment, outlier treatment, how much the accuracy is going to improve? From 55%, not going to become 85%.
Yeah.
It will become 55% to 60%. Are you satisfied with that? The answer is no. If you're not satisfied with that, then why I will go and spend time on doing missing value treatment and outlier treatment? I would rather go back and try to figure out what other variables I can add to my data set, which might increase the accuracy.
Okay.
Right? So that's why maybe sometimes I will prefer to do random forest because it will give me direction in which direction I should go, where I should spend my time first.
Yeah.
so if we do random forest, okay, you said, I mean, we will get the results even if we, don't do any data cleaning, right? Like
Yeah.
removing the outliers or missing
Mhm.
values. So if we do random forest, like, and if we get any model accuracy, so how are we going to replace those missing values or outliers, with the help of the output that we got using random forest?
Not
I
because of the
didn't get that.
no. We are not saying that based on the output, I'm gonna do missing value treatment. I'm just
Okay.
telling you, let's say you got an output, you got accuracy, 80%, right? Now you know that, okay, I can calmly go back to my data set and do missing value treatment and outlier treatment, because by doing that, I will make my data set more clean, right? Because I will make my data set more clean. If I run the iteration this time, I will get again the accuracy around 80-85%. Okay. It was not related to that I'm using the output of random forest to do missing value treatment. No, I'm using the output of random forest to decide what should I do next. Should I do missing value treatment or should I go back and look for more variables? Okay, this is the question that I'm trying to answer. I'm not trying to answer how I should do missing value treatment. I'm trying to answer whether I should be doing missing value treatment or should I be doing something else.
Okay. Can we combine two models? Like suppose if I have a data and if I have to find missing values, like I'll assume those missing values as my target variable. I mean, you got it?
No, why we want to do that? I can
If
simply
suppose I have more missing values, suppose 45% of the data is having missing,
uh-huh.
probably 30% of data is having missing values.
Uh-huh.
So I assume that as a test data and the remaining 70% as trained data. And first I try to find out, because that will improve my accuracy, right? Rather than going for different options.
No, actually the test data and trained data should always be randomly split. What you are doing right now is you are applying some logic to split between test and train, right? Some logic you are using. We should not do that. The test and train should always be divided randomly. If you will not do that, then your whole modeling exercise is wrong.
But like, can we do that like for missing values? I want to implement a model to predict the missing values, and after that I'll tune the model in a better way with some other model.
You can do that. I got your point that you will take missing values as a target variable, and then you will try to predict it. And using that prediction, we will we will populate the column, and then we will use that column to predict the target variable, right?
Yes,
This is what you're saying.
yes.
Yes, we do that actually. That is a complex way of doing missing value imputation. But
Yeah.
yes, we can do that. That is actually one of the ways in which you can do missing value treatment.
Okay.
But it is
Puneet,
possible only when there is some dependency between that missing variable and the rest of the data, right?
Very nice. Yes, Lavanya. Yes.
Puneet, can you show from that model 1 when end and 2, like could you iterate again?
Sorry, can you repeat that, Deepak?
The model 1 when we got 6.68. Can you repeat that, iterate again? Actually, I'm not able to get.
Okay, this one. Yeah, just 1 minute. This thing, right?
Yeah, after this.
Yeah. So what we have done is, okay, let me go back. Yeah. Yeah.
So till this I know. After that I maybe I missed.
Okay. So what we did was, this we had like 0.05 like these weights, right? We added all these weights and it was adding up to 0.68.
Yes.
Okay. But what I want is my rows should always add up to 1. My weight should always add. So what I did is I normalized it. If I will divide each row by 0.68, then the addition will add up to 1.
Yes.
Right. So I divided this row as well, divided by 0.68, this row also divided by 0.68, this, and so on. When you did this division, you got 0.07. So this is 0.07, 0.07, 0.07. Then I did 0.33 divided by 0.68. This gave me 0.49. So this will become 0.49.
Yeah.
Okay. Then again 0.7, 0.7, 0.7. If you'll add this up, this time it will add up to 1.
Yes.
Right. Now, once this is done, I was saying that whatever the weights that you have, weights are nothing but like duplication. More the weight, more duplicate I'm going to do that row. So just imagine as if you are duplicating this row 7 times.
Yes.
So if you will incorrectly classify this row, I will deduct 7 marks of yours.
Yeah.
If you will incorrectly classify this row, I will deduct 7 marks of yours. But if you will incorrectly classify this row, I will deduct 49 marks. Right? So what the next model will do? The next model will try to make sure that it is not predicting this particular row wrong. Okay? Because the penalty is very high for this.
Yeah.
Okay? This is how weights work, by duplicating.
Yes.
So the rows which will have higher weight will get more duplicated as compared to the rows which will have lower weights.
Yes.
Okay. What is your question now? Anything apart from this?
After this, actually, like after this, the second model you create, right?
No, the second model will be just simply, now what I will do is, I will check for each chest pain.
Yeah.
I will check for chest pain, blocked artery, patient weight. Again, using these 3 variables, I will check which variable is giving me the highest accuracy.
Okay.
Okay. This time it will not be patient weight. It might be chest pain, it might be blocked artery.
Yes.
Why it will not be patient weight? Because patient weight is making this particular row incorrectly classified.
Yes.
Right. So here there will be a penalty of 50% approximately. Approximately 50% penalty is there for this particular row.
Yes.
So patient weight will not come. Right. Now I will say, I will see that, okay, let's do it for one row. Let's take it for chest pain. Okay.
Yes.
Now for chest pain, I have yes, 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 yes. Okay. And what is the prediction for these? Yes, 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 and then no and no. So what should be my final prediction for this? For these 5 data points, should I predict yes or should I predict no?
Yes.
I should predict yes, right? If I predict yes, how many correct classifications that I'm doing? I'm doing 0.7 plus 0.07 plus 0.49 plus, sorry, that's it.
Yes. Yes.
Because the other 2 are wrong.
Yes.
Similarly, so this is for yes. Let's talk about no, this. For these, the prediction is yes, and the remaining two predictions are no and no. So what should be my final prediction?
No.
No, right? So how many correct classification that I will be able to do if I will predict that a patient is not having heart disease? These two, right?
Yes.
So that is 0.07 plus 0.07. So what is my total accuracy? My total accuracy is going to be 1, 2, 3, 4. 0.07 multiplied by 4 plus 0.49. That is 0.93.
Yeah.
Okay. So this is for having chest pain.
Yes.
Now, similarly, if I will do it for, blocked arteries, if I'll do it for blocked artery, I'll just check yes, 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 yes. This is one bucket. Now, corresponding to this bucket, I have yes, 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 and the other are no. So what should be my final prediction?
54. It's 50%, like we have.
No, it is not 50-50.
Yes.
It will be yes.
Why it will be yes? Because in favor of yes, if I will check, in favor of yes, how many votes, how many rows are there?
Okay,
1,
49.49. Okay.
Yes, exactly. So 0.07 plus 0.07 plus 0.49. For no, it is 0.07 plus 0.07 plus 0.07. So what will I predict? Yes.
Yes.
Right? Because if I predict yes, this is how these many I will be able to do correctly. Similarly, what I will do is for next, I will check no. Only two rows are there. One is yes, one is no. So anything you can check. Maybe I can take yes as a prediction. So one will be correct.
Yeah.
So total accuracy is going to be for this particular one 0.07 plus 0.07 plus 0.49. So 0.07 multiplied by 3 plus 0.49. That is 0.7, right?
Yeah.
0.7 accuracy. So previous call was giving chest pain. I was getting 0.93 as the accuracy. Here I'm getting 70% accuracy. So which variable I will split on the next? Chest pain.
Yes.
Okay. Yeah.
So we got this variable. Then how will, like, from this numbers like 0.93, 0.07? So what will get next?
0.
From the accuracy score, then how the model will, like, predict?
Now the model has selected chest pain as my next variable.
Yes.
Okay. So using just simply yes and no, right? The simple prediction that we do, that simple prediction will do on the original data set.
Okay. So chest pain will the first feature we'll use, right? We are saying to create the stump.
Yeah. Right. So we have already created one stump using patient pain.
Yeah.
This is the second stump that we are creating using chest pain.
Okay. So then again, we'll see the third stump will create the blocked arteries, right? After chest.
Right. Yes.
Okay.
Okay. And we'll keep on doing this. Then we'll get multiple models. Once we'll have multiple models, we will have accuracy for each model. For accuracy of each model, we will calculate amount of say, and then we will make the final prediction. Cool. Okay, let's do it in Python now. Not sure if we will be able to complete it today, but let's try. Okay, I'll also share the data set with you guys. Can you guys please download the code and the data set? Let me know once you have uploaded it. And please try to run the codes side by side.
Puneet, do you remember all this code or how like this? I'm not able to remember all this code or how, like when someone will ask you this code in interview this to write this code.
No one will ask you for writing this code from scratch in an interview. From an interview perspective, whatever we learned in the Python course, that is important. Like
Okay.
writing for loop, maybe plotting charts, right? Adding two columns, taking join, mainly pandas, numpy, matplotlib, and a little bit of looping and all. Okay, that is more important. This no one will ever ask you to kind of write a decision tree code from scratch or write a random forest code from scratch. See, the thing that the people ask you in general in a interview is something which can be one concept which can be applied to multiple places. But in case of machine learning, it's not like that. If I have learned the code for random forest, I will be able to write the code of AdaBoost on my own. That is not the case. Everything is different from each other. The code of logistic regression will be different, random forest will be different, AdaBoost will be different, XGBoost will be different, K-means will be different, KNN will be different. How many will you remember? And what is the point? Right? But if someone will ask you that, okay, you need to take a join between the two tables, that is a concept which can be applied to joins of any two table. Right? It's not like for table 1 and table 2, there is a different syntax. For table 2 and table 3, there's a different syntax. So there we need to remember the things. If someone will ask me that, okay, filter this data set where, let's say the gender is male, that we should be able to do it. If someone will say that, okay, create a loop and add 3 every times you make a iteration, that we should be able to do. Or write a function. And I'm assuming that those things must be covered in the Python.
And do you need to know any this Python, this Django or something to like so because this model will be used by some web framework, right? Like say you create a model, like say you are working for Myntra or something. Say you create a model of say with this model you can predict that someone will be buying or not, right? So finally that model will be used by some like some
non-tech guy.
Non-tech guy, or you want to present something to a stakeholder also, right? So then will you be creating any like temporary website or kind of thing, like web interface, so that they can play with that, or how?
No, nothing, bro. In general, like the thing, like it's more like in any company, it's more of a like I will do my work and you do your work. As simple as that. You will not interfere in mine, I will not interfere in yours. Because when you let people do those kind of a thing, they will come up with a hell lot of questions that they don't understand.
Okay.
Okay. So in general, it doesn't work that way. We do presentations, but even in the presentation, we only present the things that they should be able to understand. For
Okay.
example, what is the variables that I have used? Like how I have done missing value treatment. What is the accuracy of my model? What are different models that I have tried? What was the accuracy of each model? How much the data set I took? Have I included all the data set, or have I built this model only for desktop data or mobile data? Have I built this model only for a particular market or for all the market? Let's say, have I built this model only for US, or have I built it for US and Europe both? So those kind of questions we try to answer. We don't try to answer that how XGBoost is going to work. What will happen if you will remove this particular variable and add another variable? What will happen if I'll square this variable and then add it? That is not your job. This is what we tell them. This is our job. We have figured it out. We have done it. This is how we have done it. We just simply tell them that we have used XGBoost, right? But we don't take like these kind of a question that what will happen if I'll do this? What will happen if I'll do that? Okay. Okay, let's start. So first we will be reading a few libraries, right? I think a few of it you must have seen by now. Decision tree classifier, we used it in decision tree as well. We used it in random forest as well. We are using it here as well. Then I think these also, species accuracy score 1, we have used before. Train test rate, again, we have used it like multiple times now. Now, in the next part, what I'm doing is I'm going to upload the file. Okay, then I'm reading the file. So I have around 15,000 rows and around 10 columns. What are these 10 columns that I have? I have satisfaction level on the job, how much I scored in the last evaluation, how many number of projects that I have done so far, what is my average monthly hours, how much time I have already spent in the company, how many work-related accident which happened with me, whether there was any promotion that I got in the last 5 years or not, for which department I work, whether my salary is in the low bucket, medium bucket or high bucket. And finally, based on all of these variables, I'm going to predict whether someone will leave the company or not. Okay. In the last time, we were trying to predict whether someone will get promoted or not. This time, we are trying to predict whether someone will leave the company or not. Okay. In general, higher the satisfaction level, lower should be the chances that someone will leave the company. Last evaluation means that someone has scored high in the last evaluation. Most probably, he should not leave the company. If someone has done more number of projects, will he leave the company or not leave the company?
Not.
May leave the company, may not leave the company, because more number of projects might also indicate that that person is having less work-life balance, right? So may or may not happen, but yes, we can have our theories and then we can check in the data set what is happening. Same goes for average monthly hours as well. Maybe high monthly hours might lead to someone leaving the company. Time spent in the company. Here also, I feel that as the time spent in the company will start increasing, then there will be, let's say, higher chance that someone will leave the company. But after beyond a point, the chances will start again going down. If someone wants to leave the company, in general, they leave the company between 2 to 5 years only. If someone is working in a company for last 7 or 8 years, there is a high chance that he will not be leaving the company, right? In the next 1 year. Similarly, promotion, if you are not getting promoted, then yes, there will be high chance of you leaving. Then department, maybe a few departments will be where the people will be leaving more, for example, sales. Similarly, salary, if you are in a low salary, there is a high chance that you will be leaving the company as compared to if you are in a medium or high salary. But these are all theories. Ideally, I should check all these hypotheses. I said check all these hypotheses based on the data sets, based on different analysis that we will do. This one is going to give me the minimum, maximum, the median of all the values. So it helps me to check whether the data set is correct or not. For example, it has been mentioned that the satisfaction level is value between 0 to 1. I can see that the minimum value is 0.09, maximum value is 1, which is correct. Okay. Similarly, how much someone has scored in the last evaluation, I can check the range, number of projects, monthly hours, time spent in the company. So I can check these values, min max values, to see whether it is making sense or not. Then in the next step, we are checking whether the data type of each variable is correct or not, right? It makes sense. I believe we have department as an object. We have salary as an object. Why? Because we have high, medium, and low. It is a categorical column. What kind of categorical column it is? What are different type of categorical columns we have?
One hot encoding.
No. We have
Ordinal.
nominal and ordinal.
Nominal.
Two type,
Yeah.
right? So which kind of categorical variable salary is?
This is nominal.
Nominal.
It is
Nominal.
It is ordinal. Salary is the ordinal categorical variable. It has a order, right? Between high, medium, and low. Will you say that there is no order or there is an order?
Okay.
Yeah,
If it's order.
Right? It is a ordinal variable, right? But a categorical one, obviously. Now, what I'm checking is I'm checking the proportion of people, right? How many percentage of people who are living. So we have of 15,000 rows that we have, in which 3,500 rows approximately are for the people who are left the company, which is nothing but 24% of my data.
Hello.
Yeah.
No. Sorry. I thought.
No. I was just waiting for you guys to reach to this point. If you're running the code side by side.
Reached.
Cool. Now, so what is going to be my target variable? My target variable is going to be this column, whether someone has left or not, and my features, that my input variables is going to be all the variables except this variable, right? Again, if you look at it, this is a very standard thing that we do. From the very first machine learning technique till now, and even in the future machine learning technique, you will always see me separating the input variables and the target variables. Okay. Next part, what we are doing is we are checking the correlation. Again, it is just for our understanding to see how things are correlated with each other. Okay, it's not going to have any impact on your final modeling. We just want to see whether the variables are correlated with each other or not. Okay. To me, it looks like there is not enough variables which are correlated. So it looks like all the variables are more or less independent. Average monthly hours and the number of projects are little correlated, not very highly. So it means that the person who is doing more number of projects, he will be doing more number of average monthly hours as well.
Could you please show the cell about this correlation?
This.
Yeah, I'm getting an error while running this.
I am also getting I think string need to convert it to
convert
cells.
Same error.
String to float could not.
This code you're getting error, right?
Yes, yes. I think the sales data need to be converted to.
Can you just double check it once if the code is exactly the same or something is
Yeah,
different?
no, exactly the same. I think last time also I got. So I think we have to typecast.
No, in the correlation, right, dot core, in that include a parameter called numerical only equal to true.
No, but we have already made sure, right? Here, we are only taking int and float.
No, in our notebooks, it's not there, sir.
It's not there.
That particular.
Okay. So
include
can you
equal to
please?
int and float is not there.
Yeah. Can you please add this?
Like there's another alternative also. Like if we write numeric underscore only equal to true within the call, there won't be any issue. We don't have to include any data type.
Got it.
So what is that Vmax equal to 1 square equal to true? SNS heat map.
Vmax equal to 1 square equal to true. Let's make it false. I think now it is not a perfect square as much I know. Very stupid argument. Yeah, now it is a perfect, totally useless. Okay, so you must have seen it, right? Otherwise, it will be a little rectangle. What is Vmax?
Okay. The background.
Okay, now what I'm doing is I'm creating a bar graph between the salary, right, and the chances that whether someone will be leaving the company or not. You can see, like, as we were expecting, if someone is having high salary, then they have a less chance of leaving the company. If someone is having low salary, then they have a high chance of leaving the company. And if someone is having medium salary, then there is a medium chance of someone leaving the company. Right? Why we are checking it? We are checking is to kind of build data understanding, to see whether everything is making sense or not. Whether if there is something which is counterintuitive, if we were able to see that high salaries leading to more people leave, that will be counterintuitive.
That on the y-axis 0.00, what does that indicate? I mean, 5% of the people left, 10% of the
Yes.
people.
So this is like 7% of the people who have high salary has left the company.
Okay.
We can move on.
Okay. In the next part, what we are doing is we are checking for each department what is the
what is that CI equal to none?
Where is CI equal to none?
Here. Yeah.
Yeah. Let me check. Just 1 minute. Just 1 minute.
You say
Mm-hmm.
display the confidence interval.
Mm-hmm. Okay.
It is saying CA
Hmm.
equal to none because we are using matplotlib and not Seaborn.
Okay. It is saying that CI is nothing but confidence interval. So, okay, it is not changing anything. So ideally, if I will make it 0.90, it should give me 90% confidence interval, right? Oh, the CI parameter is deprecated. I need to use something called this. Not sure what is the impact of this. I don't think it's nothing. Anything will happen if I'll remove this.
It showed me some error when I removed that one.
Yeah, I think now it is showing the error bars. If you remove that one, this is the confidence interval, the 0.95 confidence interval.
Okay.
Okay, I think I can get back to you on this one. I believe we can discuss this more a little bit. Apart from this, we have let's keep it now. Right? Then we have promotion the last 1 year or not. If someone is getting promoted, then there should be less chance of that person leaving as compared to someone is not getting promoted. So yes, if someone is getting promoted, they have a 7% chance of leaving versus if someone is not getting promoted, they have a 24% chance of leaving. Okay, so this is also intuitively makes sense.
Sorry, your screen froze.
Okay, sorry. Yeah. Okay, so we'll wrap up for today here. Tomorrow we will discuss this code more.
Thank you.
Okay,
Yeah,
thank you.
sure. Sure. Thank you.
you.
Thank you.